Okay, Im2 peeps, hope you're doing well. Let's go ahead and do two problems from this week's assignment. Let's start with number 4. So we have standard form of a quadratic, and we're going to find the vertex and graph this thing. Once we do that, we'll find the y-intercept, and then we will kind of guess, an accurate guess of the x-intercepts. Okay? So if you watch the video, there's details on how to do this, but I'm going to show you my way, which is very similar to the video. First thing we want to do is notice that this is in standard form. It's no longer in vertex form. Okay, so standard form has a value, a b value, and a c value. So let's label those things. So my a value, b value, and c value. And this should look very familiar to you when we did factoring. We labeled a, b, and c. Okay? So what we're going to do is find our a value, which in this case is 2, our b value in this case is -8, and our c value is 4. And to find the vertex in standard form, we use a very specific formula. It's x equals -b over 2 times a. Okay? So once we know this formula, which was from the video, memorize this formula, we're going to plug in our b value here, and then our a value here. And what this does, it gives us our x value in our vertex. So once we have our x value, we then can use the x value to find the y value, and I'll show you how to do that. Okay? So we're finding the vertex point. All right, so let's do it. X equals negative, and then we're going to plug in whatever the value of b, including sign, so it's -8. So -8 over 2 times, and then whatever our a value is, which is 2. Let's clean this up. X is going to equal negative times a -8 is 8 over 2 times 2 is 4. And now we have x equals 8 divided by 4 is 2. Okay, so I can now find part of my vertex. My x value is 2. Okay, so this is my x value. Now what we're going to do is we're going to use this x value to find our y value. And the way we're going to do that is take your x value and plug it into your original standard form for every single x. Okay, so let's take our standard form. Again, we're going to turn f of x into y. So y equals 2x squared, or 2 times x squared, minus 8 times x plus 4. And now we're going to take our x value too and plug it in for x. And we're going to do all this math. So y equals 2 times 2 squared minus 8 times 2 plus 4. And then doing order of operations, let's do the math. So y equals 2 to the second, exponents first, 2 to the second is 4. So we're going to have 2 times 4 minus 8 times 2 plus 4. And let's do this multiplication. 2 times 4 is 8. -8 times 2 is -16. And bring down the +4. And then let's do adding and subtracting. 8 minus 16 is -8. -8 plus 4 is -4. Okay? So now we found our y value. Our y value is -4. So we're going to put that in. Let's erase that. And we now have our vertex of 2, -4. Okay, so let's plot that. 2, -4, 2, -1, 2, 3, 4. So again, 2, negative 4. And there's our vertex. And if you remember, we have an axis of symmetry that goes through our vertex. So our AOS is this line. And the formula for the AOS is actually x equals to whatever our x value is in our vertex, which is usually our h value, okay, from last week. But x is equal to 2. Okay, that's our axis of symmetry. Now, we want to graph, and we are going to use, if you remember, the 1, 3, 5 rule. But the 1, 3, 5 rule gets affected by the a value. If you look, my a value is 2. So that means the 1, 3, 5 rule has to be multiplied by my a value, which is 2. So my 1, 3, 5 rule turns into 2, 6, 10 rule. Okay, so that means I'm going to go over 1, up 2. There's my up 2, positive 2. So let's put a dot. Over 1, up 2. Now I'm going to go over again. Now I'm going to go up 6. 1, 2, 3, 4, 5, 6. Put a dot. Okay, and then go over again and up 10. 1, 2, 3, 4, 5, 6. As you can see, it's off my graph, so I'm not going to do that third dot. Now we are going to copy over the axis of symmetry. So we went to the right one from the axis of symmetry. We're going to go to the left one from the axis of symmetry. Right 2, left 2. All right, and here is my graph. Okay, so now let's find the y-intercept. If you recall, when you have the y-intercept, your x will be 0. Okay, so my x value is 0, which means I'm simply going to plug in x or 0 in for x's. All right, and if you remember the shortcut, y equals 2 times 0 squared minus 8 times 0 plus 4. If you do all this math, this guy and this guy, these two terms turn into 0, and you're left with your c value. So in other words, if you have standard form, your y-intercept is always your c value. So 0, 4, let's plot that point. And if you look, it's actually already plotted for us. It's right here. Here's our y-intercept. It kind of came with the graph. We got lucky. Okay? And then our x-intercepts, we want to approximate. So our x-intercepts is where does our graph touch the x-axis. So if you look, I'm going to put a dot where our graph touches the x-axis. So it's about right here. So I'm going to say that is going to be, we'll call it 1/2, comma 0. Remember, your x-intercepts always have a y value of 0. So we're going to go 0.5, comma 0 for that guy. And then where does it hit my x-intercept here? So that's 1, 2, 3. We'll go 3.5, comma 0 here. And your y value is always 0 on your x-intercepts. Okay, that's how you graph. Okay, let's do another one a little bit faster. So my a value is negative 0.5, b value is 5, and then my C value is -6. I know we're not using the C value yet, but we'll use it later. So x equals negative b over 2a. So x equals negative 0.5 all over, sorry, messed that up, that's a b value. -5 is my b value, and it's 2 times 0.5. Negative 0.5. Okay, so we have -5 on top. 2 times negative 0.5 is -1. And then -5 divided by -1 is x equal to 5. So my vertex has a 5 for the x value. Now we need to find the y value. Let's plug in 5 into these spots here. So y equals negative 0.5. 5 squared plus 5 times 5 minus 6. All right. So we have y equals negative 0.5 times 25, because 5 squared is 25, plus 25 minus 6. And then we go 0.5 times 25. We get y equals negative 12.5 plus 25 minus 6. And let's do this math. If we add and subtract this all together, we should get 6.5. So my y value for my vertex is 6.5. So let's graph that. So 5, 1, 2, 3, 4, 5, 6.5. 1, 2, 3, 4, 5. Let's do that again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, and then halfway up. Okay, there's my vertex, and we are going to do the axis of symmetry. Okay, there's the axis of symmetry, which has a equation of x equals our x value in the vertex, which is 5. Okay, and then we're going to graph doing the 1, 5, 3 rule. I'm sorry, 1, 3, 5 rule. But it is affected by our a value, and if you look, our a value is negative 0.5, negative 1/2. Okay, so how does our 1, 3, 5 rule look? So negative 0.5 times 1 is negative 0.5. Give you a little more room. Okay, negative 0.5 times 3 is negative 1.5. And negative 0.5 times 5 is negative 2.5. Okay. And this is going to be my 1, 3, 5 rule is now 0.5, negative 0.5, negative 1.5, negative 2.5. So let's do that. So we're going to go over 1 and then down, because it's negative, down 1/2. So over 1, down a half, which is actually a nice little dot right here. Okay, we're going to go over 1 and down 1 and a half. So we're in the middle spot again. Okay, and then over 1 and down a half or 2 and a half. So I do the half first because we're halfway. Half and then 2 more. 1, 2. Okay, and then copy those to the other side. And here's our graph. All right, y-intercept shortcut is always of x value of 0, and then whatever your c value is. Because when you plug in 0 here, these cancel out essentially, and we're left with our c value, and that's -6. So 0, -6. Let's put a dot there. 1, 2, 3, 4, 5, 6. Okay, so this is my y-intercept. All right, and then approximate our x values. So our x value is here and here. And remember, x values have a value for y of 0. And in this case, we have 2 x-intercepts. So this one here is going to be, again, I'm going to put 1.5. comma 0, and this one over here will go 1, 2, 3, 4, 5, 6, 7, 8.5. Again, these are approximates. Yours might be a little bit different than mine, but pretty close. All right, hopefully this helps. Have a good one.